Good morning students. Today we are going to learn the problems of complex numbers. In the previous class we discussed about what is the complex number definition and addition, subtraction, multiplication and division of a complex numbers and properties of addition and multiplication, additive inverse that is minus z and multiplicative inverse 1 by z and conjugate of a complex number and modulus of a complex number and properties of them. Today's class we are going to learn some problems related to previous class. So first problem, express the following in the form of a plus ib. In the form of a plus ib. A plus ib form లోకి కన్వర్ట్ చేయాలి. The given first problem is 1 plus I into 1 minus I. 1 plus I into 1 minus I, you have to convert it in the form of a plus ib or x plus iy or like that. Okay, means real part and imaginary part. It is in the z1 by z2. Okay, then like division, it is z1 by z2, so you have to multiply and divide with complex conjugate. Okay, denominator 1 minus I is there, you have to, its conjugate means 1 plus I, you have to multiply and divide with 1 plus I, it is plus denominator also. 1 plus I to multiply and divide cheyali. Okay, it is 1 plus. Okay, in the numerator 1 plus I into 1 plus I, that is 1 plus I whole square. In the denominator 1 minus I 1 plus I means a minus b into a minus b, that is a square minus b square. A minus b into a plus b, a square minus b square. So simplification, a plus b whole square, a square 1 square means 1, b square I square plus 2ab, that is 2i, that is 1 square means 1, I square means minus 1, minus of minus plus 1, 1 plus 1 2, and here I square equal to minus 1 and this minus and this minus will cancel out. I square equal to minus 1, so 1 minus 1 plus 2i, 1 plus 1 means 2, minus 1 plus 1 cancel, 2i by 2, 2 cancel, we get I, means only here imaginary part is there, no real part, so we can write I can be written as 0 plus I into 1. 0 plus I into 1 means it is a plus ib form, where a equal to 0, b equal to what? 1. So real part of given complex number is 0, imaginary part of given complex number is 1. Only we have to do, here we have to do multiply and divide with complex conjugate. Complex number యొక్క denominator conjugate తో multiply and divide చేయాలి. Okay, next 2 plus 5i by 4 minus 3i. It is also same, here denominator is 4 minus 3i, so we have to multiply and divide with 4 plus 3i. So 2 plus 5i by 4 minus 3i into 4 plus 3i by 4 plus 3i. So multiplication 2 into 4 8, 2 into 3i 6i, 5i into 4 20i, 5i into 3i 15i square, I into I square, a minus b into a plus b, a square 4 square minus b square 3i whole square. So 8 as it is, 6i plus 20i 26i, I square means minus 1, minus 1 means minus 15, and here 4 square means 16, 3i whole square means 3 square I square means minus 1, 3 square means 9, minus 9, minus 9, here already minus is there, minus minus plus 9. Okay, next, therefore 8 minus 15 minus 7 plus 26i by 16 plus 9 25. So separate it, minus 7 by 25 plus I into 26 by 25, a plus ib form. So real part of z equal to minus 7 by 25, it is the real part, and imaginary part of z equal to 26 by 25, a into I. Only we have to multiply and divide with conjugate of a denominator యొక్క conjugate తోని multiply and divide చేయాలి. Okay, that is the process. Next, homework problems. 2 plus I by 2 minus I. Here 2 minus I is there in the denominator, so we have to multiply with 2 plus I. Multiply and divide with 2 plus I. Next, 2 by 3 plus 4I. So we have to multiply 3 minus 4I by 3 minus 4. Okay. This is the first problem is over. Next, second problem. Find the real and imaginary parts of the following numbers. It is also same. 4 plus 2I by 1 minus 2I. Here denominator is 1 minus 2I. So we have to multiply with its complex number. Let z equal to 4 plus 2I by 1 minus 2I. Multiply and divide with 1 plus 2I by 1 plus 2I. So multiply, you get, what is the multiplication? 4 into 1, 4. 4 into 2I, 8I. 2I into 1, 2I into 1, 2I. 2I into 2I, 4I square. A minus b into a plus b, a square minus b square. 1 square minus 2I square. Next here, 4 plus 8I, 2I plus 4I square by 1 square minus 2I square. 4 as it is, 8I plus 2I, that is 10I. I square means minus 1. Minus 1 into 4 means minus 4. 1 square means 1. 2I square means 4 square I square. I square means 2 square means 4 into I square. I square means minus 1, that is minus 4. Minus of minus plus 4. This plus 4 and minus 4 is cancelled. 10I by 5. 5 1 ja 5 2 ja 2I. We are also only imaginary part that can be written as 0 plus or minus 2I. So what is the real part? Real part of z equal to 0. Imaginary part of z equal to 2. That is so. It's same like a plus ib form or real part, imaginary part is same model. Only wording, asking the question is different. Next problem, homework. 3 minus 2I by 7 plus 4I. It is also here 7 plus 4I is there. You have to multiply and divide with 7 minus 4I and simplify, you get the answer. Okay. Next, find z plus z bar and z into z bar. For the given complex numbers, you have to find z plus z bar and z into z bar, both. First one, z equal to 2 minus 3I. We have to find z plus z bar, z into z bar. Z equal to 2 minus 3I, then z bar. Z bar means what? Complex number. It is plus is conjugate number. It is 2 minus is there, so conjugate, its conjugate is 2 plus 3I. Minus unte plus, plus unte minus. Okay. Conjugate is z bar equal to 2 plus 3I. So first bit z plus z bar, that is z plus z bar equal to 2 minus 3I plus 2 plus 3I. 3I cancel. 2 plus 2, 4. Next, z into z bar, 2 minus 3I into 2 plus 3I. A minus b into a plus b. So a square minus b square. So 2 square means 4, 3I square means 9I square. I square means minus 1, minus of minus plus 9. 4 plus 9, that is 30. Okay, z into z bar equal to 13. Z plus z bar equal to 4. 2 into real part of z. Okay, next problem. Z equal to minus 1 in plus 3I. Minus 1 plus 3I. Its conjugate. Z bar equal to, only here plus is there, you have to put minus. For imaginary part, change the sign, that is the conjugate. Z bar equal to minus 1 minus 3I. So adding z plus z bar equal to, z means minus 1 plus 3I. Z bar means minus 1 minus 3I. Minus 3I plus 3I cancel. Minus 1, that is minus 2. Next, z into z bar, minus 1 plus 3I, minus 1 minus 3I. A plus b, a minus b, a square minus b square means minus 1 whole square minus 3I whole square. 3i whole square means minus 1 whole square means 1, 3i whole square means 9i square. I square means minus 1, minus of minus plus. So 1 plus 9, 1 plus 9 means 10. Z into Z bar equal to 10 and Z plus Z bar equal to minus 2. Conjugate here Z bar means you have to find conjugate. Conjugate means the imaginary part sign will be changes. If it is a plus, it becomes a minus. If it is a minus, it becomes a plus. Next, homework problems. Z equal to 4 plus 5i and fourth one Z equal to 2 plus 3i. You have to find Z plus Z bar and Z into Z bar for these two complex numbers. Okay. Next, find the modulus of following complex numbers. First one root 3 plus I. So I am comparing this given complex number Z equal to root 3 plus I equal to x plus iy. X plus iy to compare chestunnanu. What is the x real part, that is root 3, and what is the y? Y means I coefficient, imaginary part, I coefficient is 1. What is the formula? The formula for the modulus is if Z equal to x plus iy, modulus of Z equal to x square plus square root of x square plus y square. So therefore modulus of Z equal to x means here root 3, y means 1. Therefore square root of root 3 whole square plus 1 square, square and square root cancel. 3 plus 1 square means 1, square root of 3 plus 1, 3 plus 1 means 4, that is root 4 means 2. It is the modulus of given complex number root 3 plus I. Okay. You have to identify x value, y value and substitute in the formula. Square root of modulus means square root of x square plus y square. Here x equal to root 3, y equal to 1. Therefore square root of root 3 whole square plus 1 square. Root 3 whole square means 3, 1 square means 1, 3 plus 1 means 4, root 4 means total 2. Next, 3 plus 2i. 3 plus 2i, Z equal to 3 plus 2i, that is x plus iy, x equal to 3 real part, y equal to 2 imaginary part, coefficient of I. Z equal to modulus of Z equal to square root of x square plus y square, x means 3, y means 2, therefore square root of 3 square plus 2 square. 3 square means root 9, means 9, sorry, square root of 2 square means 4, that is square root of 9 plus 4, square root of 9 plus 4 means square root of 13 is the answer. Okay. Next, third one, modulus of 5 by 3 plus 4i. 5 by 3 plus 4i, here it is in the two parts, not in the form of x plus iy. So we have to convert in the x plus iy form or a plus ib form. It is lengthy process. So we will use the formula modulus of z1 by z2 equal to mod z1 by mod z2. Modulus of z1 by z2 equal to modulus of z1 by modulus of z2. So z equal to, let z equal to 5 by 3 plus 4i, that is modulus of z equal to modulus of 5 by 3 plus 4i. That implies modulus of 5 by using this one, modulus of 5 by modulus of 3 plus 4i. Okay. Modulus of 3 plus 4. Nice. That is 5 by 3 plus modulus of 4i. Modulus of 5 means real number, modulus is 5, and modulus of 3 plus 4i, square root of x square plus y square, that is square root of 3 square plus 4 square, that equal to 5 by 3 square plus 4 square means square root of 9 plus 16, 9 plus 16 means root 25, root 25 means 5, that is 5 by 5, 5 cancel, we get 1. Okay. Modulus of z1 by modulus of z2, that is numerator modulus, denominator modulus separately you have to find and divide, you get the answer. Next problem. Next problem, 3 plus 4i by 1 minus 7i. So z equal to, let z equal to 3 plus 4i by 1 minus 7i. modulus of z equal to modulus of 3 plus 4i by 1 minus 7i modulus. So modulus of z1 by z2 equal to mod z1 by mod z2, that is modulus of 3 plus 4i by modulus of 1 minus 7i. So numerator modulus here x equal to 3, y equal to 4, that is square root of 3 square plus 4 square. Here x equal to 1, denominator y equal to minus 7, square root of 1 square plus minus 7 square. So 3 square plus 4 square means square root of 9 plus 16. 1 square minus 7 square means 1 plus 49. Minus 7 square means 49. It is 25, it is 50. Root 25 by root 50. That is root 25 means 5. Root 50 means square root of 2 into 25. That is 5 by root 2 into root 25 means 5. This 5 cancel. 1 by root 2 is the answer. It is the modulus of a given complex number. It is modulus of z1 by z2, that equal to mod z1 by mod z2. Okay, next. Homework problems. 2 plus 3i by 3 plus 2i. Fifth problem. And next means we have to find the modulus, numerator modulus by denominator modulus. Next 1 plus I by 1 minus I. Next 1 by 1 minus 2i. Next 3 minus 4i by 4 plus 3i. You have to multiply these two numbers and simplify, then find the modulus, or separately modulus of z1 into modulus of z2. Anyway you can find out. సింప్లిఫై చేసిన తర్వాత మాడ్యులస్ కనుక్కోవచ్చు, లేదా డైరెక్ట్ కూడా మాడ్యులస్ కనుక్కోవచ్చు. ఓకే, అప్ టు నౌ వి డిస్కస్డ్ అబౌట్ ద ప్రాబ్లమ్స్ ఆఫ్ కాంప్లెక్స్ నంబర్స్ విచ్ కన్వర్ట్ ద a plus ib ఫార్మ్, ఫస్ట్ మెథడ్. అండ్ సెకండ్ ప్రాబ్లమ్ ఈజ్ ఫైండ్ ద రియల్ పార్ట్ అండ్ ఇమాజినరీ పార్ట్ ఆఫ్ కాంప్లెక్స్ నంబర్స్. నెక్స్ట్ కాంజుగేట్ z bar. నెక్స్ట్ modulus of a complex numbers. 4 type of problems are over. In the next class we will discuss about additive inverse, multiplicative inverse and remaining problems. Okay, do these homework problems and complete the fair notes. Okay, if you have any doubts, please send me a message on WhatsApp or call me. Okay, thank you.